There's a lot of data structures in the world of computer science, and data structure simply refers to a storage format that stores, fetches, and organizes data. In the last video, we discussed a data structure called stack. However, today we will take a look at another data structure similar to stack but with minor differences, and it's called queue. A queue is a data structure that follows the principle of first in, first out. It looks horizontal, it has a rear and a front, and data is inserted starting from the rear and they get out from the front, as you can see in front of you with this small animation. We will use Python programming language, more specifically Python object-oriented programming, to be able to build this queue. If you need to refresh your memory on some Python OOP concepts, make sure to visit my playlist, link in the description. Let us start by creating a class called queue, and this class queue will have a init method and init, and this init method will take self as parameter, and this is the only parameter it will take. However, it will initialize a self.lst instance variable and will be an empty list. Why did we do that? Because whenever you create an object, let's say q1 equal to q, whenever you create an object, this init method will be initialized, and for each object it will create for it an empty list, and this empty list represents our queue, and we will use it to actually simulate the queue. Now the first method we will create will be a method that will return for us either true or false, true if the queue is empty and false if the queue is not empty. It is very simple to do it. So def is empty self, and all we need to do is say return. And how do you find the length of the list? Because we are using a list to simulate our queue. So how do you find the length of a list? Well, you can use len self.lst. This will return for us the length of the list, and if we compare it to 0, so if the length of the list is equal to 0, that means the queue is empty. Otherwise, if it's not, then it will return for us false. The next method will be the size method. This size method will simply return the length of our queue. It is very simple, so def size self, and what I will say here is return. How do you find the length of the list? Well, it's very simple, len self.lst. This is how you can return the size of the queue. And again, I will say the list represents our queue. We are using the list to simulate this queue. Nothing fancy here, there's nothing related to the concept of queue. However, this method is related to the concept of queue, and it is called inQueue. It allows us to add elements inside of a queue, and it basically means add an element inside a queue. So what we'll go ahead and do here is def inQueue self and data. What we will do here is we will add the data inside our queue, and because we are using the list as a representative for our queue, what can we do here is use a method called append to actually add data inside this list. It is very simple. So self.list.append data. So basically I'm using the append function to actually add data inside of my queue. Let me show it to you. So if I say q1.inQueue and the data, let's say 1, and to prove that the data was inside, I will say let's print the size of our queue. So I'll say q1.size. As you can see, the size is 1 because we actually added an element. This is how you add an element inside of a queue. However, you want to also fetch this element out of a queue. How could you do that? Well, we could create a method called dqueue, and it simply means fetch or take off the element of the queue. What we'll say here is self, and first of all, we will use a condition to see if the list, or excuse me, the queue is empty. Because if the queue is empty, that means there is no element to fetch out of it. What we will do here is say if self.isEmpty. So self.isEmpty returns for us either true or false. What I will do here is say self.isEmpty equal to true. That means if the queue is empty, what I want to do here is raise an exception or simply return a message which says queue is empty. This is very simple. I will show it to you. So let me go ahead and say, well, let me first of all not add any element. Let me go ahead here and say print q1.dqueue. Let's see what will happen here. As you can see, raise exception, queue is empty. However, if the queue is not empty, that means there is at least one element to fetch. I will say else, and I will say return. I'll first return the element. And how do you actually take off an element from a list? Well, you could say self.lst.pop. So the pop method actually fetches or takes off an element from a list. So basically what this pop method will do here is when I say self.lst.pop, for example, it will take off the element at the last index, which is 3, okay? However, this is wrong in the concept of queue, because as you remember, the concept of queue says first in, first out. If we input the first element, which is 1, it will be stored in this manner inside of a list, then 2, then 3. This is how they will be stored in a list. However, the concept of queue is different. The first element that we inputted, which is 1, should be the first to get out. So how can we change this pop method and make it return for us? Instead of returning the element at the last index, I wanted to pop the element at the first index. All we need to do is simply mention the index inside these parentheses. So if I say self.lst.pop0, that means we're telling the pop function to fetch us the element at the first index inside this list. And let me actually show it to you. So q1.inQ, let me add 1, then let me copy this and add 2. So there it is, this is 2. What if I go ahead and say print q1.dq, and what do you think we will get? Will we get 1 or 2? First of all, let me take off the 0, okay? And if I run this code, as you can see, we got 2, and this is, nothing is wrong with the code, but there's a logical error, because in the concept of queue, the first element, which is 1, should be the first element to get out. What if I say pop 0, which means pop the element at the first index? As you can see, this time I got 1. Now it is better to actually create a function that will allow the user to input all the elements instead of hard coding these elements, like what we did here, as you can see right here. Instead of hard coding, let's create a function outside the class, which I will call it fillQ, and this fillQ function will take an object of Q, object Q. What I will do here is I will allow the user to input how many numbers they want. What I will do is say while true, and you'll ask, why am I building a infinite loop? Well, stick with me and you'll see what I'm doing. You'll see how we can stop this infinite loop. So if I say x equal to integer input, and I will say input a number, I will allow the user to input the number that they want, and what I will do with this number is I will store it inside my queue. So object q.inQ, the inQ method allows us to store an element inside a queue, so inQx. Basically, I'm storing the element inside my queue. However, this is an infinite loop. How could we stop it? Well, I could specify for the user input any letter to stop. So basically right now, if the user inputs, let's say, their name, something wrong will happen, an error will be occurred because we are trying to convert the string into an integer. What we can do here in this case is put this inside a try and except block. We could accept this exception or error, and we could handle this. So whenever there is an error, that means the user, for example, typed their name, there will be an error, it will be thrown inside the except block, and I could break out of it. Let me show you an example. So if I say fill q, and let me put q1 as argument, so let's go ahead and run my Python file. Let me erase this one, and let's see 1, 2, 3, 4, 5. I'll say random string right now, and boom, it's stopped. So that means the user wants to stop whenever the user inputs a string. What I will do here is actually create a display method, so def display, and it will print for me my queue. However, we know that we are using a list to represent our queue. What we can do is we could iterate inside this list and print the elements. So what I will do here is say for I in self.lst. What I will do here is say print using an S string. I could say I'll put a space right here, and I'll use something called the end keyword. And whenever you mention an end keyword next to a print statement, of course with empty string, that means you are telling Python to not skip a line, because by default print statements actually skips a line. With this end keyword, you are telling them to not skip a line. Okay, let's try it. So after filling my queue right here, I want to go ahead and say q1.display. Let's see what this method will do for us. So I'll go ahead, run my Python file, 1, 2, 3, 4, 5. Let's end it right here. As you can see, it displays our queue in the correct way, 1, 2, 3, 4, 5. However, as you can see in this animation, 1 should be here and 5 should be right there. What we could do here to fix this problem is iterate inside this list starting in the reversed way. So what we could do here is say for I in range len self self.lst, and then -1, then -1, then -1, and I'll explain later. So basically what we're doing here is actually, well, iterating in a reversed way inside the list. And instead of here saying I, now I represents the index, what I could say here is self.lst index I. So let me go ahead and write I right here. Let me show you what will happen right now. If I say 1, 2, 3, 4, 5, and it's right here, as you can see, this is better than before. Why? Because 5 is at the rear and 1 is at the front. And the front element is the element that will get out first. Because 1 was inputted as the first element, it should get out first. This is a better way to actually visualize our queue. But let me explain what I actually did. So basically we have 1, 2, 3, 4, 5 inside this list. When we set for I in self.lst, I will start with 1. Then it will print 1, then it will print 2, then 3, then 4, then 5. So basically what we want is to start with 5. Why? Because we want our 5, or the last element inputted, to be at the rear, and the first element inputted to be at the front, because it will be the first element to get out. Why I said len self.lst -1? Because the length of the list is 5 right here, but the last index is 4. So it will start with 4 and ends with 0. Why? Because -1 is excluded. And the 0 index is right here. It is this last element. And -1 here is to decrement I at each iteration. And this is why I reversed the list, or iterated in a reversed way. In the beginning of this video, I explained what is rear and front. Simply, rear is the end of the queue and front is the head of the queue. What we'll do here is create two methods that returns for us the front and rear element. This is actually very simple. We are using a list to represent our queue, right? However, when you append an element to an empty list, it is stored in the first index, which is at index 0. The next element is stored at index 1, and so on. In the concept of queue, the first element given to a queue is actually the first element at index 0 of the list. And the first element entered inside a queue is considered in the front or the head. And the rear element is considered the last element given to a queue, which means the element at the last index of the list. So what I will say here first, let's create the front method. So I will say def front, and this method will return for me the element at the front. And before we return any element, I want to make sure that my list is not empty, or excuse me, my queue is not empty. So if I say if self.isEmpty equal to true, I am checking if my list is empty. Well, if it is, I will return something like none, okay? And else, if it's not empty, what I could do here is return the element. And as I said, considering the front element in the queue is actually the first element inside a list. So basically, if we input first 1 to the queue, so 1 will be stored like this inside a list. Then we input 2, it will be stored like this, then 3. So basically what we could do here is say self.lst index 0, which will return for us 1. But remember, in the queue, 1 is actually in the front, as you can see in front of you in this animation. Same goes for the rear element. So if I say def rear self, what I could do here is copy this, paste it right over here, and let me just fix the indentation. And now I could say else return, and as you can see, the last element inputted to the queue is 3, and 3 is located at the last index of the list. What we could do is go down to the return and say return self.lst index -1. This will return the element at the last index, which in our case, or in the case of queue, will be the rear element. Let me show it to you. So if I say print, and I wrote print wrong, so print q1 dot front. This will return for me the front element. Let me copy this, paste it right over here, and say here rear. Now let's go ahead, run my code. Let me say 1, 2, 3, and let me stop right here. This is our queue. As you can see, it was printed right with the queue. Let me fix this. So an empty print statement means that we want to add a new line. Let me run my Python file again, 1, 2, 3, and let me stop right here. Okay, that's better. So basically, the front element is 1, there it is. The rear element is 3, and there it is. Now I will give you an exercise. Try to create a function that reverses a queue. Based on what we did today or right now, can you reverse a queue? Make sure to pause this video and come back for the answer. What I will do here is say def reverse queue, and it will take as parameter an object of queue, okay? First, what I'll do here is create a reversed queue object, so reverse queue equal to queue. Next, I'll create a temporary list which I will use to store the elements of the initial queue. You'll see what I'll do now. I'll say while object queue, which represents my queue, dot is empty equal to false. That means as long as my queue is not empty. What I will do here is say lst.append object queue.dq. That means I'm taking off an element of my queue and adding it inside my list. And I will keep on doing this until my queue becomes empty and this while loop will terminate. Next, what I will do here is I will iterate inside my list, but in a reversed way. And we know how to do that. So if I say for I in range, let me say range len lst -1, then -1, then -1, I am iterating in a reversed way inside my list. So I'm starting with the last index and ending at the index or the first index, which is 0. What I will say here is reversed queue dot in queue lst index I. That means I am adding or I'm fetching the element at index I of the list inside the list, and I am adding it inside my reverse queue. Let me just go ahead and print the reverse queue by mentioning reversed queue.display method. So display. Let us print actually a before and after. So what I will say here is q1.display. Let me add also a empty print statement to go to a new line. And before we do anything, I need to actually call the function reverse queue. I forgot to call it, so q1, and let us try right now. What will we get? So 1, 2, 3, and let's stop right here. As you can see, my original queue was 3, 2, 1. When you reversed it, it will become 1, 2, 3. Okay, so 1 was at the front, 3 was at the rear. Now 3 became at the front and 1 became at the rear. And this is the end of today's video. If you missed my previous video about the stack data structure, make sure to visit it right now. Otherwise, subscribe and check this video out, where we will build a simple timer in Python.